This is an audio summary for CERTIP project ER18-1026. This project was led by Damien Helbling from the School of Civil and Environmental Engineering at Cornell University and Will Dichtel from the Department of Chemistry at Northwestern University. Cyclopure was also involved in the project as a small business participant. The problem we addressed with our project is the need for cost-effective remedial technologies for groundwater contaminated with PFAS. And specifically, our project focused on developing a novel class of adsorbents with tailored affinity for PFAS. Our novel adsorbents are polymers of cyclodextrins, in which the cyclodextrins are cross-linked by a rigid aromatic compound to generate high surface area polymers with permanent mesoporosity. An example of the synthesis reaction is shown here at the top of this slide. The resulting polymer network is shown as a cartoon on the left of the slide and in its as synthesized morphology in the images on the right. And you can see the as synthesized polymer is a yellowish powder of irregular particle size. Over the course of CERTIP project ER18-1026, we synthesized dozens of novel cyclodextrin polymers, looking at different chemical cross-linkers, different cross-linking density, incorporation of co-monomers, and so on. And some of the dozens of cyclodextrin polymers that we synthesized performed really well for removing PFAS from water. I'm showing one example here that was produced from our first cyclodextrin polymer by means of a post-synthetic reduction reaction that transformed the nitriles on the crosslinker to primary amines that could be positively charged at neutral pH. We evaluated the performance of this cyclodextrin polymer to remove a mixture of 22 PFAS from water. And what we found was really excellent performance, as shown in the bottom left of this slide, with nearly all of the PFAS removed in under 4 hours of contact time, which is really remarkable performance with an adsorbent dose of only 10 milligrams per liter. On the right of the slide, I'm showing data from another study where we evaluated the performance of 3 cyclodextrin polymers alongside a powdered activated carbon PAC and an ion exchange resin, AE resin, for the removal of PFAS from an AFFF contaminated groundwater sample. We measured 68 PFAS in the groundwater sample, and we found that one of the cyclodextrin polymers, which we call CDP plus in this figure, could outperform the conventional adsorbents under these real-world conditions. Over the course of CERTIP project ER18-1026, we also developed techniques to generate cyclodextrin polymers as granules, as shown on the left of this slide, granules that are more amenable for implementation in packed bed filtration processes. We demonstrated the durability of cyclodextrin polymers in a variety of physical and chemical settings. Some of the data is shown here in the middle of the slide. And we also demonstrated that cyclodextrin polymers can be regenerated and reused without any loss of performance following a rinse with a dilute alcohol solution, and some data on this topic shown on the right of this slide. Altogether, our project has advanced the development of a novel adsorbent as a cost-effective remedial technology for groundwater contaminated with PFAS, and we hope to continue working in this vein to eventually integrate these materials into packed bed filtration processes for groundwater remediation.